Going on in Chapter 4 now, looking at Topic 4, systems of nonlinear equations in two variables. Here are the objectives. And interestingly, we're going to solve these pretty much the way we did linear systems. But the key is this is standard form of the linear equation in two variables. But in this case, one of these or both, the x or the y, will be to the second degree. That is, they are non-linear. They're going to be curves or parabolas of some type. All right, let's go on. So we're asked to solve in example 1. Now here they're going to use the substitution method. And again, take some good notes. We want to follow along. There are two equations. And you might say, what would be the easiest? Well, if we solve for y here, we would get y equals x squared. Just transpose that -1 over to this side, and that would be a +1. And that's what they're doing. So in this equation here, where there is a y, we are substituting this. So I've written it here, and now let's go to the whiteboard. And we can use our skill to solve it. So I'm going to put this in standard form, and I'd like this to be positive. So I'm going to put this over to the other side. And I get now a negative. This on the other side becomes a positive x squared plus 1. And this is already over there, -1. And now I'm going to bring this over to the other side as a -4. So all I've done is I've put this in standard form. So what does this become now? Well, this is going to be x squared minus 4x. Got to put the x there. And then what technique do we use to solve this? Well, it's in standard form. We can factor it. Now we equate each of the factors to 0. This one is already equal to 0. This is equal to 0. So we get x could equal 0, or x could equal a +4. Wanted you to see how we work that out. Let's go back to our regular board now and go to our next slide. Clear this up. And there we get our two answers. They did it in a similar way. They multiplied through and then they did this. But this is the use of substitution. Now we have here a potential of two answers. So let's see if they work. So x could be a 0. And we put that into the other equation. And they have it worked out nicely for us here. If this is 0, y could be a 1. So one of our ordered pairs could be 0, 1. And here, if x is 4, putting it into this equation, we get y is 17. So that would be the ordered pair 4, 17. All right. Now we check it, and in finding that 0 comma 1 is a solution for both equations, and 4 comma 17 is also a solution for both equations. Now, just a little aside here. We're going to go to the whiteboard for a moment. Here are our two equations in standard form. Now, I could put them into a graphing program, but I already see that we have a common y-intercept here. So we know then that 0, comma 1 would be a point of common intersection. All right, but let's take a look at the graph of this. We have a little bit of time. So I'm using Desmos.com. I put in my first equation, and this is the red parabola here. And my second equation is the blue linear equation. Our y-intercepts are 0, comma 1, and sure enough, that's what's showing up here. And expanding the graph a little bit, we see our second point of intersection is right there at 4, comma 17. So I thought it was a nice gesture to show this. And let's get back to our regular slides. In example 2, we see we have two equations that are to the second degree. They're both quadratics. So we're going to use the addition method here. We've lined them up in standard form, and you might, again, this is where you need to study a little bit and say, what could you possibly do? Well, as we look at the next slide, we see they're going to modify both equations. And let's show you that. Standard form. That if we multiply this equation by 3 and this equation by a negative 2, we get our y's to cancel out. Now you could have done the x's as well, but again, this is a judgment call. This is what they've done. So they've distributed each of these, and we get this. And then each of these, and we get this. So now we put a line underneath them, and these add out. So we're left with x squared then on this side equals 9. So using that square root method, take the square root of this side, and then plus or minus the square root of this side, we get x equals plus or minus 3. So let's look at what happens next. And this is what we've done. Now we need to go back and take our value of a positive 3, put it into the other equation, and eventually end up that y then could be a plus or minus 2. So we have a series of possible points of intersection where it could be plus or minus x, which is 3, plus or minus 3, or plus or minus 2 for the y. And then it'll go on to show you the checks of this, and here's what we get. These are our ordered pairs. And through the magic of our computer, we're going to show you what this looks like in Desmos.com. So going to Desmos, we have circular figures here. And notice our points of intersection. There, 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 and there. And it matches our ordered pairs. So a nice little addition. Let's go on. We have one more example to do. Now in example 3, we have an application where we can make a little picture here that the perimeter, which would be 2 lengths plus 2 widths, is equal to 20. That's this equation. And our area is equal to length times width. And our area here, let me erase the area, is 21. And you might say, how do we solve that? Well, I'm going to go to the whiteboard and use a method that I've used before where we want to substitute into our area formula a value for the length or width. Let's see what we can do here. So the first thing, I think you'd all agree that I can divide this equation by 2, and then this would give me length plus width equals 10. We're allowed to do that. So let's solve for the width. So the width would be 10 minus L. Okay, so now we can go into our area here with our value, and again, we're using substitution, that the width is 10 minus L. So we have L times the width, which is 10 minus L, equals 21. I think you can all agree to that. And now we're going to multiply through, get rid of parentheses. We get 10L minus L squared equals 21. Now we want our L to be positive, so I'm going to move my L to this side where it becomes positive. Move this to this side where it becomes negative. And then we have a plus 21, and that equals 0. We're now going to factor this, and I like this 0 on this side. So L, L, and then 1 is, let's see, 7 and 3 add up to 10. They both need to be negative. So here, equating each of these to 0, we have L equals 3, or L equals 7. So one of these sides, let's say the length, which is the longer usually, is 7, and the width is 3. And notice if we add all of these up, we get 14 and 6 is 21, and 7 times 3. Now you could also switch these around and say, well, the width is 7 and the length is 3, but this looks good here as we see it. All right, now let's take a look at the slides they're offering us here as we go back to our regular board. They're doing it a little different way. They got a fraction. Again, they're using the concept of substitution. I think they made it more difficult. And then when they do solve it, they get our same answers. Again, there's more than one way to do this. So the solution sets are these, and both of them work. Generally, I would have used the length as 7 and the width as 3. Okay, this will be a shorter lesson than what we've been having recently, and hopefully we're thankful.